Alright guys, welcome to another class on physics. Right, so in this class we'll be looking at dimensional analysis. Very simple. Now, a lot of students get confused when it has to do with dimensional analysis. That's why we're setting up a video to explain everything, the whole concept of dimension analysis. When it comes to dimension analysis, there are a couple of things we need to know. For instance, we need to understand the fundamental quantity. These are the three basic fundamental quantities we have in physics. We have the length, the mass, and the time. And so for dimension analysis, what we need is their first letter here, L, which is the L here, the place length, the M, which is the mass here, the place mass, and the word T, which is time, the T, which is time, the place T. The second thing we need to know about dimension analysis are the formulas of the equation we are working with. For instance, area is length times breadth. But the breadth there can also be taken as length because dimension analysis depicts that we have three basic fundamental quantities which are length, mass, and time. That means for anything that has to do with distance, we are depleting it with length. So we are changing those words for their dimension formula, which is L. Means that if we multiply L times L, we're going to have L squared. That means the dimension for area is L squared. Take for instance volume. Volume is length times breadth times height. But then anything that has to do with length, breadth, and height, we are all replacing them for length. Since distance, displacement, length, breadth, and height all has to do with their length. So for volume, we're having length times breadth times height. We can change them for length times length times length. That gives us length cube. But since we are looking for the dimension of volume, it is L times L times L. Volume gives us L cube. See how easy it is? Let's look at dimension for other derived quantities. Now, if this is your first time of joining Premium Meal Academy, kindly subscribe to our YouTube channel, share the video, and tell us what you think about the video on the comment section. The question says, what is the dimension of the following derived quantities? We have density, speed, velocity, acceleration, force, energy, and power. In this video, I'll be showing you a step-by-step guide on how to find the dimension of all fundamental quantities. There are two key steps we need to understand when solving questions as regarding to dimension analysis. Step number one, we define the equation. By that, I mean give the equation of what density is. What is the formula of density? What is the formula of speed? The formula of velocity? The formula of acceleration, force, energy, power, so on and so forth. Number two, we expand the expression in terms of the fundamental quantity that makes up the derived quantity. I'll explain. The formula for density is mass over volume. If you check the numerator, mass is a basic fundamental quantity. From the three fundamental quantities we have, length, mass, and time, the mass there is a basic fundamental quantity. And so we express it by writing m, which is what I gave you here. For mass, we express it by writing m. Now, if you check over the volume is length times breadth times height, which we said was length times length times length. And so we express it as m over L times L times L. If you express it further, we're going to have m over L cube. If we take that in our index form, it's going to be m times 1 over L cube. In doing that, we express the 1 over L cube in indices form is going to be m times L raised to power minus 3. So let's give a basic solution on the board. For density, I said for density, the formula is mass over volume. If we express this further, we're going to have mass over the volume there is length times length times the length. Alright, but then if you watch, we have expressed all of this into their basic fundamental quantity. Where we have mass, we replace it by m. That gives us m over the length gives us what? L times L times L. If we express it further, we're going to have m over L cube. Right? So we express this in the index form. We're going to have m times 1 over L cube. Now, this 1 over L cube, if we take it in our index form, it's simply going to be m times L raised to power what? Minus 3. That's what we're going to have. If you understand indices very well, we're going to have m times L raised to power minus 3. In doing that, we're going to have ml raised to the power of minus 3. That's the answer for dimension of density. So we can now say finally that density is equal to ml raised to the power of minus 3. Very simple, it's basic, right? In the sense that we have, number one, we have the formula, right, which is this. We have the equation, and then number two, we express all of this equation into their what? Into their fundamental quantities. So mass over the volume is length times length times length, which we express by using their first letters LLL, LQ, express it in this form, and we'll get our answer. Let's look at the next question, looking for the dimension of speed. See you in the next video, guys. Thank you. And now for speed is nothing more than distance over time. The distance can be replaced as what? Length. So we have at the numerator length and at the denominator over time. If you watch, both length and time are part of our basic fundamental quantities. So we have length over time, which when we express further, we're going to have length times 1 over time. And if we express the 1 over time, it's going to be length times time raised to the power of minus 1. That gives us LT raised to the power of minus 1. That's a simple answer for speed. To try and solve that, we're going to have that speed is nothing more than distance over time, right? And we know that distance can be replaced as what? As our length over time. Now both length and time are what? A part of our fundamental quantities. By doing that, we replace them by their first letter L over T. In doing that, we're going to make it L times 1 over T, such that if we express 1 over T, we're going to have LT raised to the power minus 1. Simple answer for speed. If you're good with indices, you know that when we have stuff like 1 over a raised to the power 4, the answer becomes a raised to the power minus 4. Because for us to remove this, we change it by a little minus here. That becomes a raised to the power minus 4. Very simple. Let's look at the third question, looking for the dimension of velocity. I'll see you in the next video, guys. Thank you. Velocity is nothing more than displacement over time. It has the same formula as speed, just that speed is a scalar quantity, velocity is a vector quantity. But we won't do that. We said that velocity is displacement, which is the same thing as distance over time. We can change that to be what? The length over time, which gives us what? LT raised to the power of minus 1. They are the same question. So let's solve for that. For velocity is the same thing as displacement, which is speed, displacement over time, and displacement can be exchanged for length over what? Time. Since both of them are part of our basic fundamental quantity, all we have is L over T. Just pick their first letter here, right? And by doing that, if we express them in our index form, we're going to have L times 1 over T, which gives us this 1 over T here gives us what? L of T raised to the power minus 1. Very simple, right? That's for velocity. Our dimension for velocity is LT raised to the power minus 1. Let's look at acceleration in our next video. Now, the formula for acceleration is nothing more than velocity over time, right? So we express the dimension for velocity over time. That gives us LT raised to the power of minus 1 over the time. And if we express that further, we're going to have L times T raised to the power of minus 1 times 1 over T, such that if we express our 1 over T, total equation is going to be L times T raised to the power minus 1 times T raised to the power of minus 1. Applying the T raised to the power of minus 1 in indices form, it's going to be L times T raised to the power of minus 2. That's the simple answer for acceleration. And so if we solve for acceleration, acceleration gives us acceleration gives us what? Velocity over time. That's the expression, right? But we've already gotten the value for velocity, dimension for velocity as what? As LT raised to the power of minus 1 over the time here, t. So let's express this in an index form. We're going to have LT raised to the power minus 1, the numerator, times 1 over t, such that if we express 1 over t further, we're going to have LT raised to the power of minus 1 times t raised to the power of minus 1. Now if you watch, expressing t raised to the power minus 1 and t raised to the power minus 1 in index form, we're going to have LT raised to the power of minus 1 minus 1, which gives us LT raised to the power of minus 2. Right? Remember, in indices, when we have two base, we pick one, and then since there's a times here, we sum up minus 1 plus minus 1, and minus 1 plus minus 1 gives us minus 1 minus 1, which gives us minus 2. That becomes the answer to the dimension of acceleration. Let's look at the dimension formula for force. Now, the expression for force is nothing more than mass times acceleration. And if we do that further, we're going to have m times LT bar 2. Since we already know the expression for acceleration, if we multiply all of them, we're going to have mLT raised to the power of minus 2. That's a simple answer for force. Let's solve. For that, for force is nothing more than mass. The formula is mass times acceleration. Right? And mass is a fundamental quantity, which is what? M times, we already have the expression for acceleration as what? As LT raised to the power of minus 2. If we multiply that further, we're going to have mLT raised to the power of minus 2. It's a simple answer for the dimension of force. Right? It's very simple. Let's look at the dimension for energy. Now, for energy, the equation for energy is nothing more than force times distance. That's the formula for energy. It is force times distance. And we have force as mLT raised to the power of minus 2 times the distance, which is the length, times L. Expressing that further, we're going to have m times L times L times t raised to the power of minus 2. That gives us m times L raised to the power of 2 times t raised to the power of minus 2. Very simple. That's m L raised to the power of 2 times t raised to the power of minus 2. Let's solve. In doing that, for energy, it is force times distance. Right? And force, we already have force as mLT raised to the power of minus 2 times distance, which is also the length. If we multiply further, we're going to have m times what? L. M, this m, times L times L times t raised to the power of minus 2, which gives us m L raised to the power of 2 t raised to the power of minus 2. That's a simple answer for energy. It's very simple. Just express them in terms of their fundamental quantity and then you get your answer. Having done that, I would like for you to do the last one, get the formula for power and get the dimension of power. Leave that in the comment section and let's see if you're following the class. I'll see you in the next video, guys. Thank you.